Hi everyone. So in today's video, we'll be understanding what exactly is Intersection Observer API and how we can use it in like real world application, real world React applications to implement multiple functionalities. We'll understand that by implementing a demo application which will have infinite scroll implemented using Intersection Observer API. So let's go ahead and break this video into pieces and understand what exactly is Intersection Observer API first. So Intersection Observer API provides a way to asynchronously observe changes in the intersection of a target element with an ancestor element or with a top level documents viewport. Now that was like boom, what exactly did they write over here and what does that even mean? So let's go ahead and simplify this. I have Excalibur open over here. Let's say this is one of the elements within your DOM and this is another element within your DOM. What you want to observe is if this what you want to do is you want to execute some piece of code as and when this element starts intersecting with this another element, or when this particular element comes in the view of this particular element. So there can be like multiple use cases where this might be a helpful information, and some of the examples are lazy loading images. So you might have a page wherein there are like multiple images. Let's go ahead and replicate that scenario. Let's say let me quickly replicate this particular div. Let's say this is another image, and then this is another image, and then let's say this is another image. So in a page where the user is only seeing these three images initially, you wouldn't want to load this image as well on the initial load of the page. So Intersection Observer API can help you achieve this. What you can do is you can basically start observing this particular element and figure out if this element is either in the view of the user or not. If it is not, then you wouldn't want to load this particular image. So this way you can basically lazy load your images, and as and when a specific image comes into the view of the user, then only you can basically fetch data for that particular image. So this is one of the implementation. Another one is infinite scrolling. This is something that we are going to implement in today's video as well. Third one is reporting of visibility of advertisements. So ads are basically the ad revenue is basically calculated based on whether a user saw that particular ad or not, and you can basically keep track of whether an ad was displayed in the user's viewport or not using Intersection Observer API. Deciding whether or not you want to perform an animation process based on whether the user will be able to see it or not. So these are like some of the use cases wherein Intersection Observer API can come in very handy. So let's go ahead and understand how we can implement this in by jumping onto VS Code. So I have this empty React application over here. I have cleaned up the app.js file a little bit, and there's only one h1 tag that says infinite scroll. If I go back to the browser, you can see this is how it looks right now. What we're going to do is we're going to fetch images from an API, and that API is going to be a paginated API. So by pagination, what I mean is there would be 10 images on the first page, and then incrementally we can fetch more images by going to next pages of that API. So for this, we'll be using Unsplash API. Let me quickly go ahead and open it. So this is Unsplash API. You can Google Unsplash documentation or something similar, and then you can land onto this particular documentation. You can create a developer account and then create an application within your account. From there you will be able to generate an API key, and once you generate an API key, you can use like any of these APIs to fetch data from Unsplash. So in today's video, we'll be using this particular API, list photos. And what this particular API does is it returns random images from Unsplash, and this is a paginated API. So you can basically set the number of images you want per page, and you can also specify the page you are currently on, and there are like a lot of other configurations that you can do. So you can explore more within the documentation and see like based on the application that you want to make, you can modify the API call. So we'll be using this particular API for today's video, and let me quickly show you what exactly are we going to do in today's video. So let's say these are the 4 images that we fetched from that API initially. So our per page image count is basically 4. and what we want to do is we want to implement infinite scroll for our user. So what exactly is infinite scroll? So when the user starts scrolling and when they reach the end of the number of images that we currently have, what we want to do is we want to fetch more such images. We want to fetch more images from the API. Basically, we want to fetch the next 4 images from the API by going to page 2, and this way the user can basically keep on scrolling and they'll keep on seeing more and more images. Now, how exactly do we do this? So to implement this, what we'll be doing is, let me quickly remove these extra images first, and yeah, this one as well. So let's say we initially fetch these 4 images. Now what you will do to implement this is, below all the images, or the below the div that wraps all these images, will have another div, and will basically start observing this particular div using the intersection observer API. And when the user starts scrolling, we'll see when this particular div comes into the view of the user, and as soon as this comes into the view of the user, will basically increase the page number by 1. So let's say that initially you fetched images from the first page, so our page number was initially 1, and when the user starts scrolling and this particular div comes into the view, we will increase the page count to 2 and will fetch images from the second page. And then what will happen is, we'll have 4 more images inside we'll have 4 more images below the last image, and this particular div will move below all those images, and then the user can again go on scrolling, and then this div will again come into the view, and then the page count will get increased to 3, and this will like keep on going. So this way the user will have an experience wherein they'll be scrolling through an application that has infinite scroll, and they'll be like greeted with more and more images. So this is how we are going to implement this. So let's go ahead and do this quickly in the VS Code. First of all, let me quickly create a state wherein we'll be storing the images that we fetch from Unsplash API. So I created a use state variable called images. In this we'll be storing the images that we fetch from the Unsplash API. And also let's create a state variable for storing the page number that we are currently on. And next up, I'll quickly write a function, fetch images, that will be an async function to fetch images from the Unsplash API. I have Unsplash API written in my notes, so I'll quickly copy paste it from my notes. I use Unsplash API in one of my other projects as well, so I am copy pasting the same API key from that project over here as well. Let me quickly copy paste the API key, and for obvious reasons this API key won't work after the video, so please don't try and copy paste this particular API key, because I would have deleted the project by then. So let me quickly refactor this a bit, and once we are done doing that, we'll do response.json. This is all usual stuff, and this is our fetch images function. So we have specified 10 images per page in this particular API, and the page number is dynamically being passed, and this is the client ID that is associated to my Unsplash account. Now in ideal cases, this would be this would probably be stored in like an N file, but for demo purposes I have directly hard coded it in the function itself. So for better practices, you can create a .n file and keep this API key over there. And if you're not clear about this particular syntax, what this syntax is basically doing is, it is appending the new images that we fetched from the API in the original images array. So we are not overriding or rewriting any of the images, we are appending more and more images as and when we fetch them. Now let's quickly write a use effect to basically run our fetch images function. What this particular use effect will do is, it will run initially when this particular component gets mounted. So your initial set of images will be fetched, and as and when the page number changes, it will rerun to fetch more images. So if I save this application currently, and if I quickly go to localhost :3000 and refresh this, this should ideally work. Oh, we haven't created any UI to basically display those images, so let's quickly go ahead and do that, and I'll let GPT do its job, GitHub Copilot do its job, and let it render basically divs for displaying all those images. And what we need now is like a closing bracket and this, and then a final closing div. So yeah, I think this should be enough. Yeah, so what we are doing is we are basically calling the fetch images function to fetch our initial set of images, and then we are mapping over the images array to basically render the images. Now you can go ahead and see the response of Unsplash API. We get the image URLs in this particular format. So we go to the image object, we go to the individual image object, and inside that we have this URLs key, and inside the URLs key we have this regular image variant. So you can use that particular URL, and we have also added some alt text. So yeah, you can basically console log this response to see and understand how the API response is structured, or you can also go and visit the documentation of Unsplash to basically see how the response is formatted. So you can see we get a array, and this array has individual image objects, and inside these image objects we have this URLs property, and inside this URLs property we have this regular key, and we are using this particular image URL to basically render the image. Now if I go back to our application, you can see that we are getting images being rendered on the screen. So yeah, the images are getting rendered. Now you'll notice one thing, if you go to the networks tab and reload, you'll see that the API is being called 2 times, and I hope you can basically figure out why this is happening. This is happening because of strict mode in React. So because of strict mode, it basically tries mounting a component twice to see if there are any like issues with that particular component's rendering. So if I quickly remove that and reload it, you'll see that only the API is being hit only once. So yeah, you can I am fine with the initial API call being hit twice, so I'll quickly uncomment that. And in ideal cases as well, you should never remove strict mode because it enforces good coding practices on you. So yeah, let's go ahead and move ahead with our implementation. We are fetching the data properly. I'll quickly give this image tag a specific height as well, because currently they are occupying a lot of space. So let's say the space is 400 something. I think that should be fine. Yeah, that looks good. Yeah, now what we want to do is, if I go back to Excalidraw, we wanted to create this extra div after all the images were rendered to basically start observing if this particular div comes into the viewport of the user. So let's go ahead and create this extra div, and I'll give some temporary text to this div. I'll basically say loading. So whenever the user reaches the end of all the loaded images, they'll see this text loading, and as soon as this div comes into the viewport, we'll be basically fetching more images from the Unsplash API. Let me create, so now let's begin with the implementation of intersection observer API. So we need a use effect for that. Now also let's go ahead and create a ref for our div. I'll call that loading ref, and initially it would be null. So firstly I would want to check if loading ref dot current even exists or not. If it does not exist, then I would simply return from this use effect. If it exists, then I would want to create a new instance of this intersection observer class, and I'll basically create a new instance of it. And what this class basically takes in the constructor is a callback function that runs whenever the element that you're trying to observe comes into the viewport. So we'll console log this particular argument and see what it shows. So let me quickly write console.log entries, and we'll see what it returns. And this threshold property basically tells how much amount of that particular element that you're tracking you want to consider before calling the callback function. So when you set it to 1, you're basically saying that when that entire div gets into the viewport, you want to call this callback function. So this can basically have a value from 0 to 1, and based on the value that you pass in, it will basically check if that amount of that element is in the viewport or not. So yeah, that is the setup for intersection observer. And now inside this observer instance that we have created, we have a method called observe. So let's rename this. Let's call this loading observer, and inside this instance that we have created, we have a function called observe and a method a method called observe, and inside this method we are supposed to pass in the element ref that we want to observe. So we want to observe this particular div, so we'll quickly pass the ref that we created to this particular div as well. We'll pass loading ref to this, and what we want to observe is that particular element. So, and you should always clean up your observers. If you basically mount any sort of observers to any of your element, you should always write those in the cleanup function. I'll also check if loading ref.current exists in this particular cleanup function as well, and if it exists, then I would simply go ahead and call the unobserved method and pass in the same elements ref. This will basically remove the listener from that particular element. So yeah, this is something that we can do, and let's go ahead and see what it logs in the console. So as you can see, that entries variable that we printed is basically an array, and that array basically contains all the elements that we are currently observing. So what we want to do is we want to destructure this, and we want to extract the very first element from this particular array, and that is going to be the element that is going to be this particular div element, because we are currently observing only one element, and the first element itself is going to be that particular element. So let's quickly go ahead and console log it. So you can see we get this huge object intersection observer entry, and this has like a lot of properties that we can use. So there's this property called is visible, and that property basically tells us if that particular element is in the visible range or not. So we'll basically utilize this particular property to figure out if our element is visible or not, or whether it came into the viewport of the user or not. So as soon as I scroll down and brought this particular div in the viewport of the user, you can see there's another log, and inside this we have this is intersecting property that basically tells if this particular div is intersecting with the viewport or not. And as you can see, this is intersecting property is true in this case, and we can utilize this particular property to fetch the next set of images. So let's go ahead and do that. So inside this callback function, what we would want to do is we would basically want to check this is intersecting property, and as soon as this is intersecting property turns to true, we would basically increase the page number to 2. We'll basically increase the page number by 1. So initially the page number was set to 1, and the data got fetched, and once this data got fetched and this intersection observer was registered to that particular element, the user will start scrolling, and once they start scrolling and they reach to the end of the images, that particular div that we are currently observing will come into the viewport and start intersecting with the viewport. And as soon as it starts intersecting with the viewport, we would want to increase the page number by 1, and as soon as this particular page number changes, we'd basically want to this particular use effect will rerun, because it has page in its dependency array. So as soon as you change the page number from 1 to 2, this particular use effect will run again, and eventually we'll call this particular function with page number 2, and will basically be fetching the next set of images. Now one important thing to note is we would want to keep images in the dependency array of this particular use effect. Now why exactly are we doing this? Because every time you fetch new set of images, your component will basically re-render, because this state variable will change, and as soon as it re-renders, the position of this particular div or this particular div will be remounted, and basically the reference can change. And just to be sure, what we want to do is we want to create a new observer every time the component renders. So this is why we are cleaning up the old observer every time the component unmounts, and we are creating a new observer of that particular div every time the component re-renders. So this is something that you would want to do, and let's go ahead and see this in working. So if I reload the application and open up the networks tab, let me reload again, you can see that the page 1 API was made 2 times, and then the page 2 API was also made. Now why was this made? Because initially when there were no images, that particular div was in the view itself, and so it increased the page count to 2 on the very first load, and basically as soon as the page count got increased to 2, the use effect ran again and made the API call for the second page as well. But now if you go on and keep on scrolling, once we are done with all the images, you can see that page 3 API call was made. And notice over here that you will see that loading div for like a split second while the API is being loaded or the API is fetching the data. So you see that loading text and then the API call for the next page is being made. So this is how you can like implement infinite scroll. Now let's go ahead and try to fix this issue wherein when we load the page initially, the second page API call gets made on its own. So what we can do to solve this is we can create a flag. Let's call this flag something like const is first page, and we can basically set this to true initially, and if it is the first page then we don't want to do this, and we'll change this variable once we make one fetch call. So we'll change this first page variable to false. Now what we are basically doing is for the very first page for the very first time this variable is true. Okay, so we are basically checking if the API call is being made for the first page or not, and once the first page API call is made, we are setting this variable to false, and inside this particular use effect we are checking we are basically calling the set page setter function only if this is not the first page, if this is the first page. So let's go ahead and test this out. If I quickly reload this, you will see that the 2 API calls were made. Those are because of strict mode, and now the second page API call wasn't made at the very start, but if I go on and load, you can see that the second page API call was made, and this will now work just like before. The only benefit is that the second page API call was not made at the very start. So this is how you can prevent that issue as well. So yeah, this is how you can basically utilize the intersection observer API to implement infinite scroll. The main thing that you need to focus on is this particular implementation. So you basically initialize the intersection observer API class, and you specify the callback that you want to run once that particular element that you're trying to observe comes into the viewport, and finally you start observing the element that you want to observe. And please make sure that you clean the observer in the cleanup function of the use effect. So you basically remove the event listener from that particular element when this component is unmounting. So yeah, these are the few things that you need to take care of when you're trying to implement infinite scroll, and I hope you have a better understanding of how the intersection observer API works in general. You can now, once you understand this particular code snippet, you can use this same code snippet in almost every implementation of intersection observer API and use this for multiple purposes. So I hope the implementation and the demo application and everything else was clear. Please go ahead and check out the official documentation as well. You can go to MDN docs and basically check the intersection observer API documentation over here, and you'll get to learn a lot from this particular documentation as well. I hope you like the content. If you have any doubts, do let me know in the comment section. I'll be happy to answer. Thank you and see you in the next one.